Okay. So we have gone through the networking model, which is OSI before, right? Okay. Uh, is my screen visible to everyone?
Yes, it is.
Okay, great. So we have seen these OSI open systems interconnectivity model previously, right? But the present
Yeah.
days we are using TCP IP. TCP is nothing but a transmission control protocol, and IP is a internet protocol. Everybody knows. Okay. The thing is, in OSI we have 7 layers. Okay. In OSI we have 7 layers. Okay. But when it comes to this TCP, we have 4 layers only. Okay. There is no big difference in between OSI and TCP. The thing is, a few layers in OSI is merged into a single layer, work as same. Let's assume previously I told you the application layer, presentation layer, and session layer are work at your browser end only. That means when you are going to search anything in the browser, or when you are going to using any application which is having internet connectivity or ability to transform the data or transmit the data through the internet. That means Gmail, or else on Naukri, LinkedIn, whatever it is. Okay, those kind of applications are considered as a browser or a browser end. So these 3 layers are taken care at the browser end only. After that, it is going to the transport layer, and then network, and then data, and then it is going to reach at a physical level. So TCP IP is going to consider these 3 layers in a single layer. Okay, let me show you this like this. Okay, so TCP IP is going to consider all 3 layers as an application layer. Okay, it is going to take it as an application layer, and then the transport layer is considered as a host to host, or you can call it transport layer also. And when it comes to and when it just a second, just a second. Yeah, sorry for the interruption. Okay. Oh, what's happening to my system? Yeah. So the TCP layer is going to compressing few layers of OSI layer, and it is going to take it as a single layer. So the application presentation session is happening at a application layer. That means it is going to observe and understand the data. Like it should be, if it is a sending an email to your friend or something, at that point of time at the application layer, it is going to verify what kind of application it is and what kind of port number is needed at this point of time. Okay, usually sending an email should be used by an SMTP port, a simple mail transfer protocol. But when it comes to receiving an email, is going to use a different kind of port, POP3 kind of IMAP or POP3. Those kind of ports are used for receiving an email. Okay, sending is used for, sorry, for sending email ID we use SMTP. For receiving the same email ID, the same application will use a different ports due to some their application things and all. Okay, so After that, the last two layers, data link and physical layer, is considered as a single link layer or a network access layer in TCP. So finally, operating system layer 7 layers is considered as a 4 layers in TCP IP. Okay, let's deep dig about this. Let's go. So in the application layer, as I said, user requests a service. Okay, initiates a communication for web browsing, email, file transfer, or etc. Let's assume you are going to sending an email, and that at point of time you are going to attaching your resume to that means resume is nothing but a file. So at this point of time, it needs to be add one other port also. Okay, for file transfer. Okay, and also you are going to connecting it through the web. At that point of time, again it is going to add one more port, that is called HTTP. Okay, let me give you a clear example. Oh, not this. I'll give you a clear example here. Yeah, this is Daniel. Sorry for the spelling mistakes. And this is, sorry, Chandrakala. Okay, that means your laptops or your computers are those. Daniel wants to send an email to Chandrakala. Let's consider this is a email box, or else Gmail application inside your computer. This is a Gmail application Chandrakala's computer, and this is LinkedIn. Same will be see. Okay, so if Daniel wants to send the email to Chandrakala at this point of time, Daniel computer is going to sending a request to Chandrakala, that is called sending an email. Chandrakala is going to receive that request, which is nothing but an email from Daniel. At this point of time, the laptop or a computer should need IP address. Uh, just a second. IP, which is nothing but looks like this. We can give 220.4 dot something. Sorry, something like this. And also, Chandraka is also having the IP address. Okay. So the thing is, virtually, if any device wants to connect to any other device, okay, virtually any device wants to connect to any other device throughout the internet. That's why we are calling it as virtually. It is not going to contact physically. We are going to connecting it a virtual format. At that point of time, the IP address is the recognition point. Okay, the IP address is the actual name if any device wants to connect to any other device throughout the internet. Without IP address, we can't able to send or receive data. Okay, let's assume these two laptops are in a single room. Okay, these two laptops in a single room, so you can able to connect it with a wire or a cable. Okay, you are going to connecting it with a cable. Okay, a data cable. Okay, if you connected both ends with a cable, you don't need an IP address. That means it is physically available. At this point of time, these things are going to check the MAC address. Let me give. Okay, it is going to verify the MAC address. Okay, what kind of a computer or what kind of device it is, by internally it is going to check the MAC address. What if there are some other devices also there in the same room which are connected to the same cable? Okay, let me give, this is me. Okay, I'm also having an IP of something. Yeah, and mine also have a MAC, and it is also connected with the same cable. Okay, at this point of time, all the things are connected through the cable. If Daniel wants to send something, it is going to reach to Chandrakala and me also. Okay, it is going to reach Chandrakala and me also at a time. Okay, so that means there are two or more receivers in the same connectivity, because it is connected physically with a cable. It doesn't need a virtual IP address or something. Instead, it is having a MAC addresses, but at this point of time, it is not going to check the MAC also, because the direct establishment is there. So you need to just send something, it will pass to the connectivity of the all the computers or the devices. What if there are some other uh, computers or laptops are there? Let's assume there are four or five other computers or laptops are there in the same room, which is also connected with the same cable. That means Daniel wants to send something to Chandrakala actually, but he want to refer Chandrakala. That's why he is going to refer email link to Chandrakala, but unfortunately it is going to send it to each and everyone. So everyone is going to click on that, everyone going to submit their application or the resume. So maybe Chandrakala will lose a chance to get job 100%. If all the 4 or 5% are competitors to Chandrakala, he'll lose a chance or 50-50. At that point of time, what should we do? Usually, the companies or organizations will use a switch. Okay, will use a switch. Correct me if I'm wrong. If any networking guys are there, if I'm saying any wrong or something, you can able to correct me while I'm giving the examples also, because I'm not deep dive, or I'm not deep depth knowledge into the digital devices like switches or routers. Let me attach it. Okay. I'm telling all this for an example purposes only. Okay. So at this point of time, if you use a switch, if you want to send something through Chandrakala, it is going to send it to directly to the Chandrakala only, because you are using switch. You can able to route the data to a specific device with the help of a switch. Okay, with the help of switch or a router, you can say. These things are used to send and receive data to a particular device to a particular device. So these all are called as a physical setup. At this point of time, it is going to, the Daniel's laptop is going to verify the Chandrakala's MAC IP, sorry, MAC address. Uh, With the help of that only, Daniel can able to send it to the Chandrakala. It is the configuration of a physical setup. Okay, but when it comes to the internet, we are surfing the internet, we are using the internet widely. It is a vast subject. So everything needs to travel in a virtual mode. At that point of time, you need a IP address. So at this point of time, we have observed the things previously. Let me give you where it is here. So you can see the chapter one is the application layer, user and service interaction. User request service, that means Daniel wants to send an email. At that point of time, application layer is going to assign the protocol or a port number. That means email ID, sorry, it is going to sending an email. So with a regarding to the subject, SMTP is required. At that point of time, if Daniel wants to send a file also along with the email, he is going to attaching an do's and don'ts of application, like applying. So he sent a document, a Word document, for the reason of while applying, don't need to do any mistakes. Okay, and also DNS also added, and also HTTP also added, because the data is transmitted or transmitting throughout the internet. So with the help of internet, we need HTTP because we are browsing the internet. We don't need to, actually, we are not going to browsing internet directly, but initially we are connecting our Gmail or something, but the Gmail needs an internet to transfer the data. At that point of time, it is going to use the HTTP for hypertext transfer protocol. This is a protocol. We are going to add a port number internally. After that, SMTP is going to add it, and then FTP, and then DNS. DNS is for a domain name systems are, you can say, like, it is going to find out the IP address. Usually, we attach the DNS on top of IP address. We don't need to, or anyone don't need to watch the IP addresses. Let's assume if you want to do the shopping of Flipkart, you are not going to use the IP address of the Flipkart. Simply, you are going to click flipkart.com or .in or .net based on the continent. So once you do that, DNS and ARP, okay, address resolution protocol, is going to verify what is the IP address beneath that domain name. Those things will happen. So at the point of time you're clicking sending the email, these all things are happen at a time. So protocol selection is happened, and data preparation, it means formats and encodes the data for network transmission. Okay, adding necessary headers. Okay, adding necessary headers, that means it is going to compress the data and formats the data from human readable to system readable. That means it is going to transform into a binary, and encodes, that means it is going to encrypt it. So compression is happening, formation is happening, that means data is going to transformed into some other state. Okay, at a time the encryption also happening. So data preparation is nothing but all these three. After that, port assignment. Sorry. Arey yaar. Okay. So assigning specific port numbers, well known or dynamic, for a unique application identification. That means you need a port assignment based on these protocols. Each and every protocol have a port number. Example, HTTP is 80. Okay. FTP is something. DNS is having 25. So based on the service you are going using for sending the data, you are using email service to send the data throughout the web. That means you are using the web browser, so HTTP is needed. You are using the uh, email service to send something. That means SMTP. At the point of time you are sending some file or something, so you need to file transfer protocol is needed, and also DNS also needed. Okay, so these things are happened. After that, you can see it is going to travel to the transport layer directly. Okay, it is going to the transport layer directly. At this transport layer, data segmentation, port numbering, reliability choice, and forwarding. That means we already know the data should be converted into individual packets. Simply it is broken into a small chunks or a parts. Those parts are called as a data segments. So each data segments have a little number of, or each let's consider 100 parts is going to be converted. So those are 100 parts. For each part, actually it looks like a bigger parts is going to again convert it into smaller units. So each one part is going to convert into 10. So when it comes to 100, each segment is having 10 individual data units or something. So each and every data unit again having a port number, okay, a sequence number, okay, all these things will attach. And also each data segment having 10 individual data parts or data units, small units. So it is going to give a some specific value for those 10 small parts or small data units, it is going to generate a specific value. Let's assume the value is equal to 100. Okay, for one segment it is 100. For all the 100 segments, 100 into 100 is a 10,000 something. While transferring the data, okay, it is going to verify the checksum, the data valuation is correctly received or not. Okay, once the Chandrakala received the email, that means while receiving the email and when receive the email, it is going to verifying is each and everything is transmitted properly or not. With the help of checksum only, it is going to verify it. Let's assume there only 9,900 segments only or data units only transferred. The checksum while verifying only one segment is missing. So one segment value is equal to 100. Okay, so all the 10 data units are missing. Again it is going to re-verify with the sender. Again it is going to recollect it. Once the checksum is configured, then only it is going to showcase your notification, or else you are going to end up with a error notification. You've got an email but you are not able to access it. Those kind of errors you should be ended up. So the data segmentation is happening. While data segmentation is happening, these port number assigning and all will be happening, like for the recognition purposes, all the port numbers under assigning to those segments. Let's assume it is an email, so the SMTP, and also there is a file also there, so the FTP, and also there are some other services are there. So regarding the all services, port numbers are going to assigning to each and every data segment, and also inside the data segments data units are there, the small particles, it is going to add it to that also. So reliability choice, it decides between reliable TCP or faster UDP. Let's assume you are watching an YouTube. If you don't have a high speed internet, you'll face a buffer, or uh, you'll get a kind of thing, it is loading, it will take more time to watch that, or maybe it is showcasing a 144 format. Okay, we see 144p or 1080p, that is related to the content clarity. Okay, or content quality. If it is a 1080p, it should be a very quality content, or a quality video, or a quality audio. We can able to watch it without hesitation. If the video is blurry, that means it is a 144p. That means you have an internet issue or something. But the thing is, there are two different networking things will happen in the entire world. That is a TCP or UDP. If you want send any data with the help of TCP, that should be called as a reliable data sending. If you want send, you don't need to verify it. Like you want to send the data blindly, you need to use a UDP. The difference between TCP and UDP is, let me give you, I'll write it here better. TCP is, okay, reliable resource because, okay, reliable resource because, let's assume you are sending something to this particular device. Okay, that means you are sending something to, or you are sending an email. That means Daniel wants to send email to Chandrakala. At that point of time, the computer of Daniel is going to check the Chandrakala's computer. That means, is this Chandrakala's computer are in active state or not to receive the data. Once it got confirmed, okay, it is in active state, the Chandrakala's computer again going to send acknowledgement. Okay, hey, I'm active, you can send me directly. Okay, or you can send any data directly, you don't need to worry. So after that, again Daniel's computer is going to send it. Okay, I'm sending the data. Okay, I'm sending the data. That is called three-way handshake. Okay, three-way handshakes. First, the device A wants to send to something to device B. It is going to send a request. It is going to verify it whether whether the device B is in an active state to receive the actual data or not. If Chandrakala's computer is in a shutdown state, it will never get the acknowledgement. Okay, but if Chandrakala's computer or laptop in an active state, it is going to send an acknowledgement. Hey, I already in an active state. You can send me. Okay, first you sent a request, then you got an acknowledgement. Again, once you got an acknowledgement, the device A is going to send a reverse acknowledgement to the device B. So it is happening in a three times. That's why we call it as a three-way handshake. Okay, the TCP is going to use a three-way handshake. Okay, that's why it is reliable. That means the TCP is going to verify the data is reached 100%ly to the by the receiver. The thing which I've told you earlier, we are going to evaluate. Okay, we are going to evaluate like in a specific layer the data having the data is going modified into different parts or breaking into different parts, each part called as a segment. Again, each segment is having individual small parts, those called data units. Those data units and entire the segment have a specific value that is called checksum. That checksum is not fulfilled, it is going to recheck with the sender and then receive the actual missing data. So it is happening again and again until the data received by the receiver properly. So at that point of time, they use a TCP. Okay, TCP is a reliable. Then only the SYN, that means a three-way handshake will happen. Then only the checksum will be verified it and recollected the actual data. Then only the Chandrakala is going to receive the Daniel's email address. What if they use UDP? Okay, UDP is nothing but user datagram. Okay, user UDP is faster. I'm sorry. Okay, UDP is faster but not reliable, because while Daniel wants to send an email to Chandrakala, TCP is going to requesting and acknowledging and reverse acknowledging three-way handshake will happen. Then only get to know, until unless the Chandrakala's laptop is in an active state. Let's assume Chandrakala laptop, while receiving 90% of data, it is in active state. After that, it got shut down or stuck at some point of time or lost the internet connectivity. Once the internet connectivity got, again it is going to recheck with the same thing. It is going to recheck. Okay, are you available? Ante yes, Chandrakala said okay, I'm available. Then yeah, Daniel wants to send the data. Until unless it is going to receive the data, whether it is an active state or again came back to active state, it is re-verified and then it got the actual data. That is called a TCP. It is a reliable thing. The problem is TCP should take a more time to send the data when it comes to the UDP. Okay, but the UDP don't go to send or don't go to check anything with the receiver's device. Okay, it is blindly send the data. Daniel wants to send data. If Daniel wants to use UDP, he is blindly sending. Just simply click it and don't need to verify it whether the Chandrakala system is an active state or not. Okay, at this point of time you lose the data. Maybe you'll never get the email properly. You are not able to open it because you couldn't receive the actual 100% data. So data should be corrupted. You can't able to open it, you can't able to read it. Okay, but the thing is UDP is faster. Okay, some kind of applications are using UDP, but most of the applications are using TCP. Okay, let's assume I told you like an example of YouTube video, right? If you have enough internet, while you are connecting, while you want to watch YouTube, you will definitely watch high quality videos because UDP is used by the, okay, because UDP is used by the, I'm sorry, some message I've got. Yeah. So these YouTube guys are using the UDP to send the data fasterly instead of checking this TCP reliable or something. If YouTube wants to use a TCP instead of UDP, maybe you will take some more time to watch a video. Let's assume while you are opening or searching like reconnaissance videos or something, you'll get it immediately. If you have an internet connectivity, you'll get it immediately. But if they are going to use a TCP, it will take some time to load. A fraction of seconds should be, a latency should be there. To eliminate that, they are using UDP. There are some other examples also there for UDP. If you want to play any games like BGMI, like the PUBG, if you want to play the PUBG, if you have a high speed internet, you'll use it. There is no ping, okay, because they are using UDP. If you don't have an internet facility or something, you'll end up with a glitch or something. You can't able to play that fastly. Okay, but when it comes to these CIA triad, when it comes to the applications and when it comes to the data security and all, most of the applications are using TCP. Let's assume the Gmail, like Google email or something, or LinkedIn, or else you can say like any kind of application, like even Zoom or anything, are mostly using a TCP. Because if anything wants to send to any end, like any receiver, it should be needed to deliver it properly. Maybe it should take more time, that's fine. While you are sending an email, it definitely needs to Chandrakala. That means you have to use the TCP. Okay, you don't need to broke, or you don't need to miss any email or any data while sending it to an employee or to any friend or a colleague or any person. Okay, these are important things. That's why the applications are using TCP. So most of the applications are using TCP for a reliable data. Maybe you'll end up with a latency kind of thing or something, but you'll get it definitely. Even though your system got crashed or you lost an internet while the data is transmitting, or while you're receiving an email, again once you got the connectivity, internet connectivity, you'll receive it definitely. Within a point of time, you'll definitely receive it. Okay, again. So, yeah. So the reliability choice decides between reliable TCP or fast UDP delivery mechanism. Okay, usually it is going to the applications which we are going to build. Suppose the Microsoft is going to choose these things. Actually, my data should be use a TCP, or my data should be use a UDP to transmit the data. It is happening at this transport layer, the second layer. After that, forwarding passes the segments to the internet layer for routing. It is going to the, yeah. So once it is reached the third layer, which is internet layer, okay, it is going to the packet formation. Okay, encapsulate segments into packets for datagram and IP addressing. Okay, that means it is going to adding the IP addresses of a source and a destination. Okay, and routing decisions determines the best path for packet to traveling across network. It is immediately verifying within a fraction of seconds. It is going to verify which route is best in the internet, which is the best route to send this data. Okay, that path determination is happening at a time. And also packet fragmentation, break down large packets if necessary for transmission over smaller MTU links. The thing is, we have discussed something previously, like if the device is having the capacity of receiving some amount of data, like only 1 MB speed it can be able to download, but if you are sending it in a 10 Mbps or 10 MB speed, it is going to verify it at descent. Okay, packet fragmentation, IP addressing, packet farming, and routing determination or path determination, it is going to the network access layer. Okay, at this point, packet to frame conversion will happen. The previous chapter in the internet chapter, only IP address, only logical address only attached, and the best route of like path determination is happening. After that, we are going to add the actual physical address, the MAC address we are going to attaching to the actual segments. The segments already having the source and the destination, and also we are going to adding the MAC addresses at this point of time. Okay, let me go to the where it is. Yeah, you can see this is the packet flow step by step guide. Once the browser request, okay, it is going to the DNS resolution. It is going to verify what is beneath of that IP address. It is going to verify with a DNS, like a domain name resolution or something you can say. After that, a packet creation. DNS query, what's the IP of the google.com? And also it is going to verifying and sending through the TCP IP, and then go to the ARP, address resolution protocol. Okay, who has this specific? Okay, finding the router's MAC address. You know something, we usually assume, okay, I'm using Wi-Fi, and while we are using Wi-Fi address, the Wi-Fi address physical address, sorry, the Wi-Fi address actual public IP address is going to representing. So it is directly contacting the Google, or else it is directly contacting the web while you are going to use any Google, or while you are going to use Netflix or any kind of thing. But the thing is, there are multiple routers in the world while we are going to transform or transmitting the data, or requesting something. While you are going to request to access the Netflix in your browser, it is going to cross at least 3 or 4 or many routers in the actual world. Okay, like if you are going to use the if you sorry, if you want to browse that, or if you want to watch anything in the Netflix while you are going to log into the Netflix, it is going to cross your router. Okay, the which is having you inside your home. Once the router is got lost the data from you, it is going to crossing to, or it is going to connect to the internet service provider's router. There is a big router outside there at somewhere. The internet service provider is going to taking this data from your router to their router. After that, the router is going to sending, the internet service provider's router is going to sending it to some other router, which is need to be accessible, like which is having related to that Netflix. Okay, maybe Netflix having different routers throughout the world. The data is going to the nearby router. Okay, it is crossing 3 or 4 routers. That routing is called HOP. Okay, the routing is called HOP. Let me show you. Yeah, what is HOP? HOP is one device to device transfer of a packets between network devices, usually routers. Okay, each router a packet passes through is equal to 1. That is nothing but, if the data is passing through your router, that is 1 HOP, from your router to internet service provider router. Okay, it is going to cross one HOP, means one router it is crossed. After the data is crossing your internet service provider also, again it is called 2 HOP. That is, you can see, home router is 1 HOP, it is crossed, it is going to the internet services provider router HOP2, and ISP core router. Okay, maybe internet service provider. Okay, let it assume Geo having a actual router in a major router in Hyderabad. Because I am in Hyderabad, I am sending the data with the help of my router. It is called HOP1. So it is going to reaching the major router in the Hyderabad. It is called as a HOP2. Again, it is going to the ISP core router, which is having in a different country, or maybe in a Delhi or something, which is HOP3. After that, it is going to reach the Google Edge router, or maybe the Netflix router. Okay, the actual services router, it is called HOP4. There are total 4 HOPs over there. Okay, while anything mentioning HOP, you have to consider HOP is nothing but passing a data or a data packets in between routers or a devices is called as a HOP. Understood? So yeah, so the browser request to the DNS resolution, after verifying the IP address beneath of that, it is going to the packet creation. That means the source IP address to the destination IP. It is going to assign. After that, address resolution protocol. It is going to find out who is this router. Instead, like the IP address is attached to the router, which is representing the every device connected to this router. It is going to find out this router. Okay. After that finding, it is going to find out router's MAC address. Okay, the physical address. You can see Ethernet frame. Okay, so it is going to find out the MAC address of this particular router, and again it is going to attach that MAC address, the source MAC. You can see this image. Wait, this image, it is called network interface card inside the device. Your laptop also have this NIC. Your router is also have this NIC. Your mobile also have this NIC. So the devices who is having the ability to connect to outer world through the internet, that is only happening with the with the help of this NIC, network interface card. So the MAC address is assigned to this network interface card. So each network interface card is having a MAC address, that is called physical address, because it is physically inside the device. So it is going to find out the router's IP first. With the help of IP, it is going to find out the MAC address of that IP. Okay, the MAC address is going to attaching to that frame. Attaching to that address are the segments. Those segments is going to send it to the actual destination. Okay, while finding out, it is going to sending to that actual destination. Okay, it is called router forwarding or something, you can simply say. The actual thing is MAC address is the actual address which will never be replaced by anyone. Let me show you. MAC, I'll show the image instead. Yeah, see. This is the address, MAC address. This is the physical MAC address. It is representing the first 3 octets. Okay, it is a 48 bit. Okay, when it comes to the IPv4, IPv4 stands for 32 bit, that is having 4 octets, but MAC is having 6 octets, that is called 48 bit. Okay, 8 plus 8 plus 8 plus 8, that means 32, and again 8 plus 8, 16. 32 plus 16 is 48. Okay, it stands for the first 3 octets are representing identifier. That means the company who is going to manufacturing this, whether it is a network interface card or who are manufacturing the specific laptop or a mobile or a PC or any device. Okay, it is representing the manufacturer simply, and last 3 octets are representing the actual uh, details of your device. Okay, it is representing to your device. It is representing by the manufacturer. Let's assume if Intel, or let's assume Dell, you are using a Dell laptop. The 3 octets are representing Dell. The last 3 octets are representing your laptop. Inside the Dell, there are lakhs of laptops are there, but for recognizing your laptop, it is having a unique identification number, that is MAC address. In that MAC address also, first 3 are representing your company, last 3 representing your specific device. Even if you are using 2 uh, Dell laptops, maybe the first 3 octets representing same, but the last 3 octets will be different. Understood? Okay, it is assigned by the manufacturer. Okay, let me go to that. Not this one. This one. Yeah. So it is going to simply transforming the data with the help of this. I've written the same thing. Okay, in a scenario based also. Okay, browsing application layer frame, you type google.com, browser creates an http or http request. Okay, DNS resolution, what is the IP of the google.com? Okay, directly it is not going to connect into the google.com the domain, because device can able to contact other device with the help of IP address only. They don't know about these DNS names. For our recognition and also for our security, that means organization don't want to showcase the IP addresses because of the threats will happen. Okay, if you find out the IP address, we can able to try to find out the vulnerabilities inside the server. Simply the server is having this IP. The Google's actual application server is having some IP. So masking that IP, they create a domain name, and also it will have a two kind of use cases. One, we don't need to remember the IP of that. You can simply remember Google. That's it. If you try to Google it, it is directly redirected here. At this point of time, once you click that, the second thing is a DNS resolution will happen. It is going to find out the IP address of the Google, then only the data can able to transfer to that specific Google server, or the request is going to send to that Google server. After that, a frame packet creation, you can see it is mentioned application layer. Okay, at the browser end, after the DNS resolution also happened to the application layer. After that, packet creation, you can see layer 4 and 3. Okay, TCP segment created, IP packet is created. Okay, that means a source IP, your IP, destination IP, that means Google IP is going to attach it here. And frame 4, ARP critical, that means address resolution protocol is attached. Okay, how do I reach it outside my network? System will ask. Okay, needs to route MAC. Okay, MAC address is different compared to the IP address. So ARP is going to find out. Okay, ARP who has this 192.168.1.1. The router replace I am 192.168.1.1. My MAC is this. Like this way, the ARP is going to find out the actual MAC address behind the or on top of the IP address. Okay. After the frame 4, you can go to the frame 5. Now the frame looks like source MAC, that means your MAC, and destination MAC. Okay, your router MAC address, and also source IP, your IP, and destination IP, the Google IP. That means the router also need to transfer the actual data to you only, instead of who are using the or who are connected to the Wi-Fi router inside your home. You don't want to send it to your brother or your friend. So it needs your MAC address also. Again, it needs the router MAC address also with the help of network interface card. Again, the source IP and destination IP. Your router's IP and Google's IP. Okay. And then frame 6, router hop. Router removes old MAC, adds new MAC for the next hop. IP remains unchanged. That means I told you it is going to change different routers while it is going to connect the actual Google. Okay, it is going to cross the data is crossed your router inside Wi-Fi router. It is going to connect to the internet service provider's actual router near to your destination. That is a major router. It is transforming the millions of requests. After that, again it is going to transferring the data to the actual main service providers hub or main service providers, the biggest router. That router is going to transferring it to the data to the actual Google router. That is called hop or hopping. So each and every router is crossing, that is called considering hop 1. So if it is crossed 4 routers, it is hop 4. That means it is changing the MAC addresses at every time, but the IP address won't be changed. Okay, your router's IP won't be changed until unless it reached the server. Okay, maybe while transferring the data, like service internet service providers MAC or any other like Google IP MAC or whatever it is going to changing until unless it is reached the Google server, but the IP address won't be changed. Okay, so the Google server receives the actual data. Okay, frame to the packet, packet to the segment to the data. Okay, Google sends a response back, same process in reverse. The same thing will happen again. The Google wants to send the data to us. It is again going to cross the Google's router. After crossing the Google router, it is going to touch our internet service provider's router. Our internet service provider router is going to send it to our actual Wi-Fi router. Our Wi-Fi router again send it back to our computer, like who are requesting the actual or who are browsing the actual Google. So this is the actual frame formation is happening while we are clicking or while we are doing anything. The same way it is happening. I'm just showcase the browser request instead of a browser request. If you are going to send an email also, the same thing will happen. It is going to find out behind the IP address from where it needs to be sent, and that it is going to find out the destination IP address along with it is going to find out the destination IP's MAC address, like the router's MAC. The router's MAC is going to find out from to whom I need to send it to. Once the destination is connected to, once it is happened, it is going to connected to you directly. This thing is happening while you are sending an email or receiving an email. Okay, this is just a packet or a frame or a data is transmitting in between few devices through the internet. Okay, through the internet you can see MAC address should be changed while packet is transforming or transmitting between the devices. Okay, but IP address will never change because IP should be constant. With the help of IP address only, the data will receive or sent. Okay, I'm giving the examples also. Let me close this thing. So where it is? Yeah. So in the network access layer, the packet to frame conversion happened. After that, the MAC address is going to adding, and then we are going to use the error detection. That means is that specific data, like the 100% data, is transferred properly or not. If we miss any frame, or if we miss any segment, or if we miss any packet or a data unit, again and again, still it is going to find out to receive the data until unless it got 100%, and then the physical transmission happen. Okay, till the error detection it is going to touch your routers. Once it is touched your router, it is going to, with the help of a LAN cable which is connected to your router to your computer, or through the Wi-Fi wirelessly, it is going to sending it to your computer directly. So these are the actual four layers inside the TCP/IP. There is no much difference. The thing is, the few layers of OSI layer is converting into a single layer. That's it. In the last networking layer, data link and physical layer acting as a single layer. That is called a network access layer. Okay, data link and physical layer. Usually, packet framing, MAC addressing, error detection is happening at the data link layer. Okay, source and destination physical like MAC addresses are attaching, and error detection is happening at the data link layer. And the physical layer is always a physical layer, but two layers are merged here and converted as a network access layer. Okay, in the internet layer also same. Okay, you can see. Okay, so the thing is, there is no much difference between TCP or OSI layers. The thing is, you have to understand how the data is transmitting between the devices, or the devices are how communicating with the help of these layers. Okay, I'll send you this presentation along with the document with a real-time examples. You can just read once. Okay, just read once. Yeah, you can see. While sending a single email or something which is having a file, okay, that is having at least four protocols. At the application layer, four protocols should be needed. That protocols having these kind of IPs. Okay, and it is using a transport purpose like a TCP or UDP. At the same time, it is using a internet or IP like internet protocol, ICMP or OSPF or ARP. Maybe all the four also you have to need to receive the data, and also network access, Ethernet or Wi-Fi. This is a basic frame formatting. Okay, whatever you are sending, it need an IP address, public IP address, like a source and destination addresses, along with the source and destination MAC addresses. At this point of time, sometimes you are just connecting or you are just sending and receiving it, okay, with the help of router, like a Wi-Fi router only. But internally the Wi-Fi router is also having a mechanism like this NAT, a network address transmission. Okay, with the help of that only, the Wi-Fi is giving the actual result to you instead of sending it or push it to some other which is connected to the Wi-Fi. If n number of devices are connected to the Wi-Fi, the NAT can able to find out who asked this one and who needs to receive this one, like that. Okay.
So router can find depends on the who asked, who received, going to depends on the IP only.
No, no, no. Actually, IP router is going to assign you a private IP. Okay. Router is also know your MAC address. Again, router is also give you a private IP. It's, you can simply say the router is give you a nickname to identify you. Okay, it is going to give you a specific nickname to identify you. Let's assume there are three individual devices in your home which is connected to your Wi-Fi address. Sorry, your Wi-Fi router. Okay, it is going to give you some individual private IPs. Let's assume 192.168.0.1 is your mobile's private IP, which is given by this router for recognition purposes. And this one, this is your laptop. Again, it is also connected to the Wi-Fi. That's why the Wi-Fi given this. Let's. Okay. So this way it is going to find out. So it is already know while you are connecting this class through your mobile. That means the router know it needs to be send this data, or it needs to be send a request to the Zoom server from this device directly to Zoom server. Once the Zoom server responds, the response also contact the router. Router is going to send it back to you instead of sending your computer or something, because you haven't connected it through your computer. You are connected it through your mobile only. Okay, it is going to find out. Okay, inside this Wi-Fi router there is a NAT, or there network address transmission is happening inside the router. That network address transmission NAT is going to create table. Okay, inside the table it is going to route this specific IP. Okay, this specific IP wants to connect Zoom, it will create like that. And then the below IP wants to connect to Facebook, so it is going to create a table instantly while you are requesting to log into Zoom or something. So again, the request is reached the Zoom reverse send the acknowledgement or send the response, right? Once it is reached the router is get to know, okay, inside the NAT this specific person asked the Zoom. Okay, it will reroute it to you. The mechanism will happen inside the router like this. The NAT, network address transmission, is going to take care about which device wants to connect to this, and also it is going to modify, or it is going to verify that a public IP address into private IP address. That means Zoom is having a public IP, right? That public IP address needs to send it to this private IP address or something. It is going to happen. The network address transmission is happening at this point. Whatever it is happening in the router, like in the Wi-Fi router, it is taken care by the NAT only. The NAT only, the responsible thing, is going to send and receive the data, and send and receive the data accordingly to which device to which device. Okay, again, at the same time, you are using you are browsing the Instagram in your laptop. Okay, it is going to added here. Okay, it is going to verify it. This specific device wants to connect it to the Instagram. Okay, for example only I'm explaining it this way, but NAT have a different functionality. It is going to read and write and verify the devices details and all. Okay, these details are given by the router. It is going to recognize it by the NAT. Okay, internally you don't have a public IP addresses because you have connected to the Wi-Fi. The Wi-Fi's have the public IP, but you all three are using the internet with the help of this Wi-Fi. Outside the world, when it comes to the Zoom, like Instagram or Facebook or whatever it is, it just get to know only the router. This is only the actual device which is connecting to all the things. But internally, the device is just going to collect the data and sending it to you. That's why it is going to called as a router. It is simply routing which device wants to connect to the other device. Maybe Zoom is an application, but Zoom is hosted in a specific device, right? We call it as a server. So from this computer or from this mobile to that server, or again that server to your mobile. Okay, that is called routing, traffic routing. The traffic routing is taken care by the routers. That's why call it as a routers. Inside the routers, instead of confusing, the NAT is there. NAT is going to write everything. Who wants to connect to whom, and whom wants to send the data to who. Okay, this way it is going to happen. You got it, Chandrakala?
Yeah, Sai, you said that only one router is in our home. Just we are using different devices.
Yeah.
Without connecting the cables, we are using IP addresses that belongs to the our own router. It's creating. Then we have the router in our home, and we are connecting to the one system to other system through the cables. On the time, no need to create the IP address. It will goes to the through MAC address only, right?
Yes, yes. That means let's assume if this one you are asking. This one, right? You are saying the
Yeah.
previous one. See,
Yes, just I'm getting a clarity that are not.
if you want to transfer a file from your laptop to your mobile, what do you do?
Yeah, usually we are sending through email or
No, no, no,
Bluetooth
no, no, no.
connection.
There is no internet connectivity.
We use through cable.
Yeah, definitely, right?
Mm.
If the internet is not there, what is the resource? With the help of cable only, you have to send the data. Okay, let's assume there is a cable which is having different ends. That means a C port, USB connectivity, and some other things. So each and
Mm.
every let it looks like a 5-pin cable or something. Each pin you have connected each and every device. Okay, or else you can simply say there is a single cable which is having individual ends, like same kind of ends. Okay, one individual cable, one end is having USB connectivity that is connected to your laptop, other end is having 5 individual USB connectivity cables. That means it can able to connect it to 5 individual computers. Okay, at this point of time, if data wants to send to someone, maybe it should be a difficult thing. Usually you say I can able to select which device is there and I can send it, right? But the thing is sometimes you'll end up with some kind of errors or something. Instead of you're sending it to one device, it is going to send to other device, or instead of you're sending it a single device, it is going to received by all the 4 or 5 devices. At that point of time, we use switches. Okay, these are physical mechanisms. You don't need to know about this, but for example, for a generic idea only, I'm just explaining. There is a switch. Okay, kind of a device placed in the middle of all the computers. Each and every computer is going to connect to that switch with the help of cable. So you'll simply get to know which device is connected to switch. It can showcase device 1, device 2, device 3, device 4 like that. So if you want to send a specific data to device 1, you can simply send it to device 1 only. The switch won't send it to device 2 or 3 or 4. It will stop the access to other devices. Or if you want to send the data to one or two devices, like a specific devices, it is simply going to allow to send it to the data to the specific devices only. It won't going to send it to the other devices which you are not opted. So this is called as a physical mechanism. Okay, based on the capacity of the switch and based on the capacity of the cable, the data is going to transfer. Let's assume you want to send a file from your mobile to your laptop. It should take a minute or maybe 5 minutes time based on the cable and based on the connectivity. But when it comes to the internet, it should be a different thing, right? Because we are using the virtual connectivity, we are not using any cables or anything, because I'm just connecting my Wi-Fi router. Okay, that is a radio frequency. It is connecting through the radio signals only. I'm not connected with the cable. I'm not connecting my Wi-Fi with the cable. I'm using the Wi-Fi. Even though if you are connecting with the cable also, the Wi-Fi wants to, or the router wants to send the data to the internet service provider's router. The internet service provider router is going to again send it to the actual application router. Like if you want to watch the Netflix, it is going to sending it to the Netflix directly. What I'm saying is, while you are watching the Netflix, your router and Wi-Fi router is the source and receiver endpoints. In between, there are multiple routers will come up for fast data transmission. Okay, the internet service provider wants to is going to create a individual routers from city level and state level and country level and continental level for speed data transmission. Let's assume there is no much data transmission routers are there. If you want to connect to the Netflix, it will take more time. That is called latency. If you want to connect to the Netflix, the actual Netflix servers are in a USA. Okay, it is in a USA. You want to connect to that, but the thing is, it is in a too far way. There is no middleman or middle device is there to send the data fastly. You'll end up with a glitch or something. That's why the internet service providers are making individual devices, which is called routers, in between city level and distance level. It is going to establishing. So it is simply going to crossing. Let me create one more example. This is yours. This is a Netflix. In between 3 or 4.
One more doubt also here.
Yeah.
For the internet guys and Netflix is a different, internet is a different. The endpoint there also have to get the access to every network from other who are
Sorry, you are
providing that.
saying sorry, you are saying this internet is
Yeah.
different.
Yeah, internet guys is different. Internet process is all different. They don't have any data from them. They are providing just service only, network service only. What you said, the ICANN or something, anything. The other entertainment channels and all different.
See,
They
buddy,
are
whoever see, you are asking about this and IANA. These are the actual people are the actual organizations taken care of the internet and connectivity between the devices. So let's assume IP addresses, domain names, protocols or ports. All the things
that
throughout the internet is taken care by these guys. That means assigning and reassigning. That means you have purchased a domain. After some time, what it is, subscription got ended. So you lose your IP address. Again, it came back to the ICANN or the domain provider, which is like the domain provider like GoDaddy or something. If the domain provider also couldn't make the subscription from ICANN in a yearly basis or something, it is again go back to the ICANN directly. ICANN again going to sell it to any other individual domain provider. Okay, the thing is, whoever is using, whether it is a Netflix, Amazon, you, me, whoever it is, or whatever, what kind of application it is completely based on these ICANN rules and regulations. The internet is the actual actual medium to transfer each and everything. Okay,
Yeah, the
they are just
internet is the
controlling
actual.
it. They are not having it. They are just controlling it. They cannot able to start or stop the internet, but they can control it. Okay, like who wants to use, who don't wants to use, maybe they can control it. They cannot completely shut down the internet. They cannot completely stop the these IP addresses and all. Okay, it is an open system. Internet, is a open medium to connect everyone. Okay, for the controlling purpose only, the ICANN and IAN, internet assigned numbers authority, or internet, this ICANN something, is going to just taking care of the controlling of the internet and these internet connectivity between the devices. That's it. They are not authorized to start or stop. Even though they don't have the access to start or stop, because it can't be started, it can't be stopped. Okay, okay, it is a medium only. Internet is a medium.
No, one moment. Internet is just a mediator to providing service. I understand that completely. We
Okay.
are we are logging with the Gmail or Google or
Yeah.
any other service providers like entertainment, also Amazon, Prime or Netflix, anything. They
Okay.
are merging through the internet service provider. They are merging to them, or we are going to merging to them. How they will
See,
get the
see, see. Let me
authority to
tell you. Let
provide
me tell
to.
you. Let me tell you. Internet is a medium which is, okay, which is taken care by these people. But the thing is, it is also, okay, it is also taken care by the individual governments. Let's assume if you want to use the internet, okay, you are using maybe Geo or Airtel broadband, or maybe Geo SIM or Airtel SIM for mobile connectivity or internet connectivity. Okay, the government of India is going to give the access to the domain name, like, sorry, internet service providers. They are going to give the a specific amount of time for giving the service. Okay, if the Geo wants to give you the service, like internet service, the Geo wants to pay some amount to the government, then the government only allow the Geo to give you the internet. If the internet
Sai, one
wants,
moment.
yeah,
I'm not asking about the internet side. I understand completely about internet side, but
okay,
these private channels, the
okay,
providing their entertainment service, or just take a movie also, they are releasing in the
uh-huh.
on site like that.
Mhm.
How they are doing? They are merging with the internet guys, or they are buying some
it's
rights
it's
to
not it's not
release.
merging or doing something. Simply whatever you are going to do based on created by the rules of these ICANN and IANA. That means if you want to give your service, that means if you want to watch Netflix is a domain name, right?
Hmm.
Netflix.com or .in or .net or whatever it is. So the Netflix domain is given by this ICANN. Okay, and for the Netflix also, you have to use some kind of ports and protocols, HTTP or
Okay,
whatever it is. Those
okay, I
ports and
understand
protocols also
completely.
given by the
Yes.
ICANN. The thing is,
Yeah.
at some point of time, to use the domain, to use those ports and protocols, let's assume if you want to connect to MySQL service or something, okay, that MySQL have a fixed port number. Okay, that MySQL have a fixed port number. Okay, for the lifetime, for yearly subscription or few years of subscription, MySQL is going to purchase it from the ICANN. Okay, if the
Yeah.
subscription got ended in the 10 years, if the SQL or MySQL is don't want to renewal the subscription, then again it is open to the world. If you want to create a service and you want to add this port to that service, you can able to purchase it from ICANN. If it is available in the market, you can purchase it. Okay, these are just a noun, like connectivity details of a medium which is called internet. Let me do one thing. Tomorrow I'll explain you how the devices are transmitting, like what is internet, what kind of things are happening, and who are controlling, and what much level they are going to control it, and how it is happening. Especially I'm going to explain it in India level, at least how it is happening. Okay, it is just nothing but, have you guys heard about 2G spectrum scam or 3G spectrum or 5G? At least in your mobiles 4G 5G will there, right? Okay,
Yes,
those
we have
are,
5G.
yeah, those are actually open to everyone. But the thing is, if you want to if you want to use that, like if you want to use a 5G speed or 5G technology, you need a SIM card, right? The SIM card providers are going to take the permission from the governments. Let's assume Geo wants to take the permission from the government, like Indian government. For that, the Geo needs to either pay some amount, or Geo needs to go for the bidding, or like Geo, Airtel, whoever it is, who wants to use that or who wants to provide that 5G to any individual customer, they want to go to bidding to the Indian government. If Geo got the bidding, okay, Geo successfully got the bidding, Geo is going to give you the 5G thing with the help of SIM, and Geo is going to make a towers for the 5G. Okay, then only you are going to use it. If there is no SIM card, there is no government approval, but the 5G is actually there, but you don't have a medium, sorry, you don't have a device to use it. How can you use that? Okay, the government is just giving or just controlling the, that is 5G or something. Okay, or that what it is called, the technology. Government cannot completely stop or sorry, cannot control in a full way. Maybe they can stop or start it, or they can give the permissions to specific people can use it, or specific people cannot be used. Okay, it is nothing but just controlling, the same way ICANN and IANA will do. They are just controlling, and they are just registering the details. Let's assume the MySQL is having this port number. This is a fixed port number, so MySQL can able to access, or MySQL can only be add this port number to any other device, because MySQL already paid some amount to the ICANN to registering this till lifetime.
I got it, Sai. I understand. They're buying rights from the mainly ICANN.
Exactly,
They're
exactly,
providing vast service to how much they want, how long they want. Any
exactly.
other companies.
Exactly, exactly.
I
We'll do
understand.
one thing. We'll go for this network connectivity models tomorrow. At least my mistake only. I have to explain that first, but I've missed that, and I've directly explained this IP and MAC addresses. Maybe you guys get confused. We'll do that tomorrow.
I have a small doubt, not
Okay.
this related one. You
Okay.
told me in the beginning session CAA,
Yeah,
model,
confidentiality,
right?
integrity.
Triangle one.
Uh-huh.
Uh, that one is not a chain system, right? Those one three availability,
See, those
integrity.
are a kind of fundamentals. Let's assume
Oh,
uh, if you want to create a company, for suppose you, me, Daniel want to create a or establish a soap company, a natural soap, or we are going to manufacture it. We are going to create some pillars for that. Okay, we don't want to use chemicals. Okay, at any cost. That is a one kind of a pillar, and we have to sell it a 100-gram soap only, and we don't want to sell it to the children, because if anything happen to children, it will impact our business or something like that. So these kind of pillars are business models to our business. The same way, throughout the internet, who are using the internet and these kind of things, the companies also created some pillars. Those are called CIA, continuity, sorry, confidentiality, integrity, and availability.
confidentiality.
So
Hmm.
if a company using that CIA triad, that means those are almost all secured in all ways, until unless it is happened in a application level, like what we are learning today. like any kind of vulnerabilities inside the application. If the vulnerabilities is not there in the application and they are using CA trade, that is 100% secure. But
So
the thing is,
CA,
yeah, please.
yeah, CA is controlling the endpoint or in the middleware.
Buddy, those are rules and regulations. What is CAA? Let me open that doc once.
The confidentiality, integrity, availability is happening in the all the process or in the
Everything. What
endpoint.
is confidentiality?
Confidentiality is going to the starting to ending that's
That
needed
is
to
called
get the service.
authentication and authorization. Let's assume I am hosting this Zoom call. You cannot host this. That is called, but you guys are added here. You joined here. You're listening my words. Okay, because you are authenticated, you have a username, password. You have joined the Zoom call, but you cannot able to share your screen. Okay, until unless I give you the host, but I can able to share my screen because I have the authorization access. Okay, that means only the authorized people only can able to access a specific things is called authorization. Okay, joining into a company is called, or giving your credentials is called a authentication. Accessing a specific limited period of specific files, maybe it is a secret files or important files, is called authorization. That means no one have, not everyone have the authorization. When it comes to the bank, there are 10 people working, 10 employees in a specific bank. Is everyone can able to access the vault, key vault?
No,
Let's assume clerk is there. Clerk can able to access the vault.
no.
Only cashier or manager or maybe assistant manager can have the authorization to access the vault. So confidentiality is nothing but authorization, authentication kind of thing. And when it comes to integrity, that means the cash is there, the gold is there. That means